Moving on to question 6, which states, which of the following graphs below represents a body moving with uniform retardation? And so these graphs are all velocity time graphs, so it shows that the rate of change of velocity with time. The downward slope shows deceleration, and the straight line shows that deceleration is constant. Option A is wrong because while it does show deceleration, the deceleration is not constant, so there is no uniform retardation. Option B is wrong because it shows that the object's velocity is increasing with time, so that shows uniform acceleration. Option C shows constant velocity.
This is Her Majesty is a World. Please subscribe and share my videos. Much love from me to you.
Okay, hello everyone. My name is Akajugo Amuchazi, and welcome to Her Majesty Easy World Science channel. So today we'll be looking at the Physics Waec 2022 objectives. So what I have done is I have typed out the questions first, and then given and written down an explanation beneath the questions. So let's begin. Question 1 states, the area under a forced time graph represents what? So option A, changing kinetic energy, option B, option C, and option D. So firstly, we will need to show a representative or an example force time graph. And this is shown below, where force is on the y-axis and time is on the x-axis. And the area under the graph is force multiplied by time. But if you recall, the product of force and time is impulse. However, impulse is not an option. So we need to find a property that is equivalent to impulse. So the short answer is the equivalent of impulse is the change in momentum. And we will briefly show this below. And of course, this is based on Newton's second law of motion. So if we apply Newton's second law of motion, which states that F, which is the force applied, is equal to mass times acceleration, we're able to show that impulse is equal to the change in momentum. So if you recall, acceleration is equal to the rate of change of velocity with time. And so if you substitute the acceleration with delta v over t, you have the second line shown. And then if you cross multiply, you have F times t, which is impulse, and that's equal to mass times the change in velocity. And the mass times the change in velocity is equal to the change in momentum. So therefore, the final answer is option B. Question 2. From the principle of flotation, a body sinks in a fluid until it displaces a quantity of fluid equal to its own what? And so, to answer this question, we first need to understand Archimedes' principle, because the flotation principle is an application of Archimedes' principle. So Archimedes' principle states that the exerted upward buoyant force on a fully or partially immersed body in the fluid is equal to the weight of the fluid displaced by the body. Therefore, the buoyant force is equal to the weight of the fluid displaced. The flotation principle, therefore, is an application of Archimedes' principle. So say that if the weight of the object is greater than the buoyant force, the object sinks. If the weight of the object is less than the buoyant force, the object will float. And if the weight of the object is equal to the buoyant force, the object hovers in the fluid. So therefore, the final answer is option C. Moving on to question 3. Suppose 3 identical steel balls Q, R, and S are placed on an undulating ground, as illustrated in the diagram above. Which of the balls is or are in neutral equilibrium? And so first of all, we need to understand what neutral equilibrium means. So it states that if a body remains in its new position when disturbed from its previous position, it is said to be in a state of neutral equilibrium. Also, the gravitational potential energy of the ball remains constant in this position. And so if you analyze the positions of the ball, the correct answer turns out to be option A, which is S only. Now question 4. The length of a simple pendulum is increased by a factor of 4. By what factor is its period increased? So there are a few things we need to understand about this question first. First of all, what is period? We know that period, which is often denoted by the capital letter T, is the time taken to complete one oscillation. And it is also the inverse of frequency. And so there's an equation that relates period to length and gravity. This is shown below, where period is equal to 2 pi multiplied by the square root of L over G. So from this we see that the period of a simple pendulum is directly proportional to the square root of the length of the pendulum, since 2 pi is a constant. And if you keep everything else constant and increase the length by a factor of 4, to find the increase in period, we need to find the square root of 4. The square root of 4 is equal to 2. So therefore, the final answer is option B. We also see that the period is inversely proportional to the square root of the acceleration due to gravity. And so some other things that might be helpful. A. The period T is independent of the mass, the size, the shape, or material of the pendulum, provided that the pendulum is of constant length. B. The period T is also independent of the amplitude of oscillation, provided it is small. Now question 5. The linear expansivity alpha and cubic expansivity gamma of a material are related by which equation? And this is something that you have to know. There are means to prove it, but it's often not required. And so you just know that the cubic expansivity is 3 times that of the linear expansivity of the same material. Therefore, the answer is option B. It's also good to know that the area expansivity is twice that of the linear expansivity of the same material. Moving on to question 6, which states, which of the following graphs below represents a body moving with uniform retardation? And so these graphs are all velocity time graphs, so it shows that the rate of change of velocity with time. And we understand that retardation means slowing down. Uniform representation is shown by a graph with a straight downward sloping diagonal line. The downward slope shows deceleration, and the straight line shows that deceleration is constant. Option A is wrong because while it does show deceleration, the deceleration is not constant, so there is no uniform retardation. Option B is wrong because it shows that the object's velocity is increasing with time, so that shows uniform acceleration. Option C shows constant velocity with time, so the object is neither speeding up nor slowing down. Therefore, the only correct answer is option D. Moving on to question 7. The correct relationship between the displacement s of a particle initially at rest in a linear motion and the time t is? Final answer is option D. Question 8. The joule is equivalent to which of the following options? So this question might require a little bit of solving to get to the answer. And so we need to understand what the joule is first. We know that the joule is the work done in moving, and that's equal to the force multiplied by the distance. So now we understand that the force is measured in newtons and the distance is measured in meters. So the unit is Newton meters. That's Newton multiplied by meters to Newton meters. Now, if you look at the options, we have meters in the options, but we don't have newtons in the options. So we need to convert the force in newtons. And so now we have to recall from Newton's laws that force measured in newtons is equal to mass times acceleration. And the unit for mass is kilograms. The unit for acceleration is meter per second squared. So an alternative unit for force is kilogram meter per second squared. And so if you multiply force by distance, you have kilogram meter squared per second squared. Therefore, the final answer is option C, kilogram meter per second squared. Moving on to question 9. Which of the following statements is or are correct about a fixed mass of gas compressed in an inexpansible container? The first one, the average speed of the molecule increases. Second, the temperature of the gas increases. Third, the molecules hit the walls of the container more often than before the compression. So, compressing the gas means that the volume of the container decreases. As a result, there is less space inside the container for gas molecules. This will lead to more frequent collisions with the walls of the container. And assuming this is an ideal gas where energy isn't lost, the average energy of the gas molecules will increase, thus leading to an increase in the temperature of the gas. Temperature of the gas molecules and the average speed are related, so as one increases, the other will increase. So therefore, the final answer is D, which is all three options. Question 10. Which of these is an example of a mechanical wave? So first of all, what is a mechanical wave? So the graph below will help differentiate between a mechanical wave and electromagnetic waves. And so you might want to pause the video at this time to take a look at the differences between a mechanical wave and an electromagnetic wave. So other examples of electromagnetic waves include radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. So therefore, the only answer is option A, water waves. Question 11. Which of the following descriptions of the image formed by a plane mirror is not correct? And so to understand this question, you first need to know the characteristics of images formed by a plane mirror. And these are shown in the diagram below. So you might want to pause and take a look at the characteristics. Okay. So take your time to look through the characteristics of an image formed by a plane mirror. So by means of elimination, the final answer is C. The image is not bigger than the object. Moving on to question 12. The efficiency of a wheel and axle is 100% and the ratio of their radii is 5:1. Calculate the effort required to lift a load of mass 20 kilograms using this machine. So first of all, we need to find the velocity ratio and the mechanical advantage. And before we do that, we need to convert the mass to newtons. To convert the mass in kilograms to newtons, you simply multiply the mass by 10 to get you the weight in newtons. And so you know that the velocity ratio for the wheel and axle is the larger radius divided by the smaller radius, which is already given to us, the ratio of 5:1. And know that mechanical advantage is load over effort. We're given the load as 200 newtons, but we don't have the effort. And now there's a formula that links both mechanical advantage and velocity ratio. That's the efficiency formula. And so that efficiency is equal to mechanical advantage divided by velocity ratio multiplied by 100. So if you plug in the values that we have, you will be able to determine the effort put into the machine. And so the final answer is option C, 40 newtons. Okay, so you might need to pause to take a look at the steps before going forward.
Hi, my name is Cheryl.
And I'm Jennifer.
Guess what? There's a channel called Some Majesty Easy World Science.
And do you know the best part?
Mm-hmm.
It makes science so easy. Wow.
It makes science easy, simplified, and very, very fun.
Guess what? Rocket science ain't rocket science anymore.
It's now ABC.
Like if you did science your entire life.
Another thing about Some Majesty Easy World Science channel is that he makes available laboratory equipment and reagents.
Guess the best part? If chemistry has been hard for you, he does tutorials.
And another thing is when you order for these things, they are high quality and they are also cheap and affordable for anybody.
If you want to order, just look at the number below the screen.
And don't forget to subscribe and hit the little notification button down below.
Don't forget to share, of course, obviously there's love in sharing.
Thank you. See you there.
Question 13. A freely suspended compass needle on the Earth's surface settles in a plane called what? The correct answer is B, the magnetic meridian. When a magnetic needle is suspended freely, it aligns itself in the direction of the magnetic north pole and south pole of the Earth. The north pole of the needle gets attracted to the magnetic south pole of the Earth, and the south gets repelled equally away from it. These are definitions that you will need to memorize in order to answer further questions in the future. Question 14. An object is placed at different distances u from a converging lens of focal length 15 centimeters. For what value of u does the lens act as a simple microscope? The final answer is option C. So a converging lens is the same thing as a convex lens. So when the person uses a convex lens as some simple magnifying glass, then the object must be placed at a distance less than the focal length. And so by application, a converging lens is sometimes used as a magnifying glass. So then again, the final answer is C. Question 15. The periodic rise and fall in the intensity of sound produced when two notes of nearly equal frequencies are sounded together is called what? And this, the correct answer is option B, which is beat. Once again, this is a definition you would have to know. To briefly explain some of the other options, the Doppler effect. This is also known as the Doppler shift, and this describes the changes in frequency of any kind of sound or light wave produced by a moving source with respect to an observer. So for example, an observer is in a stationary position and there's a moving source and the observer, which the observer is of course looking at. So the change in frequency of any sound or light wave produced by that moving source is what is called the Doppler effect. Next, wave interference. So this is a phenomenon that occurs where two waves meet while traveling along the same medium. Now, resonance. Resonance describes the phenomenon of increased amplitude that occurs when the frequency of an applied force is equal or close to a natural frequency of the system on which it acts. So moving on to question 16. The power of a lens is plus 2.5 d. What is its radius of curvature? So first thing to note, the d represents diopter, which is also known as lens power. Now there's a relationship between diopter and the focal length. So this relationship will help us find the focal length. And from then on, we can easily determine the radius of curvature from the focal length. There is also a relationship between the focal length and the radius of curvature. So first of all, the relationship between the diopter or lens power and the focal length. The diopter is equal to 1000 divided by the focal length, but the focal length has to be in millimeters for this to be correct. So plugging in the values, we can see that the focal length comes out to 400 millimeters. Okay, and so moving on, the focal length multiplied by 2 is equal to the radius of curvature. So we have the focal length as 400 millimeters. And if you multiply that by 2, we have a radius of curvature of 800 millimeters. But don't forget the question requests an answer in centimeters. So to convert from 800 millimeters to centimeters, you simply divide by 10. So we get the radius of curvature as 80 centimeters. Therefore, the final answer is option D. Moving on, question 17. The reason for having a large number of turns in the coil of a moving coil galvanometer is to serve what purpose? And so first of all, we need to understand what a moving coil galvanometer is. So this is an instrument which is used to measure electric currents. It's a very sensitive electromagnetic device which can measure low currents even of the order of a few microamperes. And so the final answer is B. Once again, this is something that is standard and should be known. The sensitivity is increased by having a large number of turns. Moving on to question 18. Current is passed through two parallel conductors in the same direction. I.e., if the conductors are placed near each other, what will happen? So the final answer. When two parallel wires carrying current in the same direction, they exert equal and opposite attractive forces on each other due to the magnetic force between them. So therefore they will attract each other. So therefore option D is the correct answer. Question 19. The period of a 10 kHz radio wave is traveling at 3.0 times 10 to the power 8 meters per second is what? And so this question is rather straightforward, because if you remember from one of the previous questions, we're asking for the relationship between period and frequency. Now we're given the frequency in kilohertz, so we have to first convert from kilohertz to hertz. Let's convert from kilohertz to hertz. You multiply by 1000. So a frequency of 10 kilohertz is equal to a frequency of 10,000 hertz. And if you recall that period is the inverse of frequency, you simply do the frequency raised by -1, or 1 divided by the frequency to give you the period. That's 1.0 times 10 to the power -4 seconds. And of course, all the answers are in seconds, so the unit for period is seconds. So the final answer is option B, 1.0 times 10 to the power -4. Moving on to question 20. The magnetic material produced from the chemical combination of metal oxides that has a very high resistance to electrical current is called what? The final answer is option A, a ferrite substance. Ferrites are generally hard, brittle, and grey or black. They're usually composed of iron oxide and one or more other metals such as aluminum, magnesium, manganese, cobalt. This high resistance to electricity is desirable in the coils of transformers to reduce eddy currents. So that is one application you do need to be aware of. Question 21. A body of mass m moving with velocity v has a wavelength lambda associated with it. This phenomenon is called what? And the correct answer is option A. And the actual name of this equation is known as the de Broglie wavelength equation, where lambda is equal to h over mv, where lambda of course is the wavelength, h is Planck's constant, which is 6.626 times 10 to the power -34, m is the mass, and v is the velocity. 22. Which of the following statements about a straight current carrying wire placed in a uniform magnetic field is correct? So the direction of the magnetic force acting on a current carrying wire in a uniform magnetic field is perpendicular to the direction of the current. So therefore, applying this principle, option B is the correct answer. Question 23. 3 cells, each of EMV 1.1 volts and internal resistance 2 ohms, are connected in parallel across a 3 ohm resistor. Determine the current in the resistor. Now the method of connection will greatly impact how you will solve this question. So first of all, we need to set up a circuit diagram to make it easier for us to visualize the question. And of course, we need to bear in mind that each cell has an internal resistance of 2 ohms. So this is a rough diagram showing the parallel connection of 3 cells, each with a voltage of 1.1 volts. And so because the cells are connected in parallel, the effective EMF is equal to 1.1 volts, not 3.3 volts. If the cells are connected in series, then the effective EMF would be 3.3 volts. And so we know this from an established formula that V voltage is equal to current times resistance. And so if you want to break it down to consider the internal resistance, V is equal to current multiplied by the addition of the external resistance plus the internal resistance. So know that the external resistance is 3 ohms, because that is the resistance of the external resistor. And so now we need to find the sum of the internal resistance of the cells. And if you recall, to find the sum of resistance of the cells in parallel is 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3, depending on how many cells there are. And so plugging in this, you get R as 1 over R to be equal to 3 over 2, and therefore R is equal to 2 over 3 ohms. So applying the formula and making the current the studies of the formula, that is I is equal to V divided by the sum of the external resistance plus the internal resistance. So therefore we get our final answer to be C, 0.30 amperes. Question 24. Which of the following statements about electric potential energy is not correct? So first of all, what is electric potential energy? The electric potential energy is energy that is needed to move a charge against an electric field. When work is done on a positive test charge to move from one location to another, potential energy increases and electric potential increases, so option A is correct. The opposite is true for a negative charge, so option B is correct. The work done in taking a charge around a closed loop in an electric field generated by fixed charges is 0. And that is a fact. So option D is correct. So therefore the only answer by way of elimination that isn't correct is option C. Question 25. A galvanometer with a full-scale deflection of 20 milliamperes is converted to read 8 volt by connecting a 395 ohm resistor in series with it. Determine the internal resistance of the galvanometer. So this is quite similar to question 23 in terms of the dealing with internal resistance. The formula still remains the same, where the effective EMF or the voltage is equal to the current multiplied by the addition of the external resistance and the internal resistance. We're given an external resistance R, we're given the current in milliamps, so you will need to convert that to amperes by dividing by 1000. We're given the effective voltage. So if you plug in the values as we did in question 23, you'll get your answer as 5 ohms. And the final answer therefore is option B, option B, 5 ohms.